So, welcome to my talk about not using Godot to make video games. Not suggesting you use something else to make video games, I'm just suggesting to make something else with Godot as well. So, who am I? My name is Peter van Braam. Everybody calls me HP, please feel free to do the same. I've been, when I was preparing for the presentation, I was like, how long I've been working on Godot? So I did a little Git log, and it turns out February 2017 is the date that I started working in Godot. In 2018, I decided that working on data center infrastructure, life is too short for that sort of thing. So I started a company to do Godot Consulting, Prehensile Tales. Still exists. And I'm a board member and treasurer of the Godot Foundation. So if you have any spare money lying around, please feel free. So what I want to talk about today is a project that we've been working on called Mepon, Molecular Science and Engineering Platform 1. And it is called 1 because that was a domain name that was available. It's free. I don't know if any of you are aware of sort of like the whole state of the art of nanotechnology and things like that. But somewhere in the 70s, Mr. Eric Drexler came up with the term nanotechnology. And it's been stuck in his head ever since. He wrote several books about it, and he's quite famous on the field. I think there are several science fiction books that I wrote, that I read. I didn't overwrite. That I read that talks about the Drexler matter and things like that, and how as this Eric Drexler. So he contacted us a couple of years ago. Actually, I think he contacted one. But what he wanted to do was he wanted to build a tool to design nanoscale machines and teach people about sort of like the chemistry and the engineering involved with this. And he decided that the best way to do that would be by using a game engine because he wanted the 3D visualization of it, and he wanted an easy on-ramp for novices to try to learn about what this field is like. So we've been working on this thing about 2 years now, and we did an official launch in March 2025. The nice thing about the MSAP1 name is that it is also the domain name. So if you're interested in downloading this tool, you can. It's entirely free and open source. So what was the point of this project? So we wanted to take all of the open source tools surrounding molecular dynamics, simulation, things like that, and put it in a shell that was actually usable by people that don't necessarily know all of these stuff. And the other problem is that in this field there is a lot of research being done and there's a lot of software being written, but the problem is that this software tends to be written by scientists, and scientists are fantastic at doing science. I mean, it's in the name and everything. But one of the things that they're not necessarily very good at is UX. And that even extends to things like file formats, of like configuration file formats, etc. So the kind of that task that we set for ourselves was find a way to use all of this highly specialized scientific code and integrate it into a environment that the scientists would be happy to use, but also that people that just want to learn about like what is this nano stuff, like what is this people have this picture in their head is that as soon as things get small enough that you can't say anything about it anymore, right? There's the curse of popular science education about quantum mechanics. Like atoms really do exist, right? There really are things that are called atoms that together make up things. So it's not just this soup of entirely probabilistic stuff. Of course, there is some of that, but once you have like a bunch of atoms together, you really can say things about it. They really have properties. Like a small number of atoms really does act like a ball, right? So the other thing is, in order to teach people one of these obviously slight frustrations of mine to people, we wanted to make sure that this tool was easily accessible, but also we wanted to add some gaming elements to it. We haven't done that yet, so my presentation title is still valid. There are no bays there. And the goal is to make sure that with enough people sort of trying things, that they might actually come up with some interesting designs. One of the things we're hoping, for instance, for is somebody who can use our tools to design a energy efficient way of, say, scrubbing CO2 from the air, things like that. So I don't know if you heard about this little engine called Godot. It's pretty cool. We built the entire thing on top of Godot, and I'm going to show you the tool in a little bit. So why I get the game engine, right? So the funding for the MSAP platform is entirely from what we call bored billionaires, but people think that this is something that should happen, but don't necessarily know if this is going to make any money or not. So this is all done on donation basis, and that means that we couldn't spend as much money as maybe you would have wanted for a project of this size. So we needed to find a way of building this thing for all the platforms that people care about. And the thing is, most of the molecular scientists actually really do use Linux systems. So the system had to work on that. But again, if we want to put this thing on Steam and have non-scientists work on this, it's going to have to be able to run on Windows, right? And, well, if we've done Windows and Linux, I guess we might as well do an OS X build as well. So we did that. So the whole thing is in 3D, and obviously Godot has pretty great support for that. And the other thing is that it has really complex UI requirements. I will show you that in a minute as well. But looking at other game engines, Unity, Unreal, whatever else, like in Deer, Injui, whatever, the UI systems that exist in those game engines are definitely made for games, which is great because, you know, they're game engines and all. But Godot, the Godot's editor itself is also a Godot project. So the engine is written in itself, at least the editor is. So because of this design decision, we actually have a really complex and really rich UI system that can be leveraged for this kind of stuff. So that's why Godot worked really well for us. And I would like to go to the next slide, though. This is a picture of some of the visualizations we've done. So this is a real, well, this is obviously a screenshot. This is a thing we render in real time. So this is about, I believe, 5,000 or so atoms rendered in the so-called ball and stick visualization. This is a little different than what maybe you've seen sometimes, but I'll show some of that as well. I do see this is like, it feels very gamey, but it's also actually scientifically accurate. So one of the reasons why we use Godot, or about Trace, or one of Godot, is it's open source, because one of the goals of this project is to build a community of what we call citizen engineers to design things and figure things out and see how things like could work at this scale. And in order to give it away, we couldn't, like, we wanted to use an open source. As I talked about, very powerful UI system and GD scripts. A GD script allows us to make super rapid changes to the editor and iterates very fast on features. Because I am like a data center designer that turned video game engine developer. I am not a molecular scientist, right? I can design UX and I can use UX and figure out if it's like usable, but I can't design tools for scientists to use, right? So in our team, we have UI designers, we have a couple of scientists that use the tool. And so being able to basically fire off rapid fire builds to users. But okay, how about this, right? Okay, you want to make how do you call that? Crossing over it. Mirrored? Well, sure. Let's go for mirror. We want to make a mirrored crystal. What is sort of like, what is the use case or what is the workflow that you want to have in order to do this? And I don't know. I'd never wanted to make a mirror crystal on a computer. I'm still not sure exactly why you want to do that, but this is apparently a thing that people get very excited about. So one of the things we do is we talk, we build a version, give it to the to an actual scientist to figure out whether or not it's usable, and we can sometimes give them like 5, 6, 7 builds in an hour, right? So that works really, and so this is then a huge time save. And of course, Godot is a super cute robot logo, and you can't ignore that from those. If you have 3 engines and one of them has a cute robot logo and they're otherwise identical, you're gonna go. So how do we actually talk to this nano world? As I talked about, these scientific tools are tend to be written in a combination of Python, NumPy, and sometimes some C++, sometimes other stuff. Point is that there's a bunch of CUDA in there. It's a gigantic mess of different languages. And in order to kind of like protect both the engine from all of this mess and all of this mess from the engine, we've decided to basically run all of these tools in their own little Python environments and talk to these Python environments using ZeroMQ. I don't know if is anyone aware of ZeroMQ? 1, 2, 3. Okay, I'm going to give you a very quick explanation. ZeroMQ is a message queue, and zero stands for because you don't have a sort of like a separate message queue server. So what we've done is we implement a ZeroMQ process inside the editor. It's inside the Godot engine that then talks to different ZeroMQ instances that run in these little Python containers, essentially. ZeroMQ, you can view it as a abstraction on top of networking. Basically, it gives you a higher level tool set on top of kind of unreliable networking. And this Python and Godot bridge works really fast and reliable, and we like it a lot. Okay, I'm gonna try and show this thing now. So we'll see how this goes. I had it running here. There we go. So the primary reason for showing this thing is kind of showing sort of like the type of like complex UI that you can actually achieve with Godot if you give it a chance. So the center of the screen is largely essentially a like quite a normal 3D viewport, right? So we can create some. I'm gonna have to use 2 hands. See if this goes. Technology, I've heard of it. Can you still hear me? Yeah. Sorry. Yeah. So we can put together a quick, very not scientifically accurate molecule here, and we can very easily add these little balls together. And the interesting thing here is this is all rendered. Well, it's obviously rendered on the GPU, but this entire thing is rendered as a shader. So we upload the topology of the workspace to the GPU as a list of things, and then we have a shader that actually turns it into this visualization. Another thing we've added here is an ability to add sort of like more atoms at places that nature would like you to put atoms, which is definitely not what I've done here. But we can solve that too. So as I said earlier, we've like integrated with these molecular dynamics tools, and one of the things it gives us is a way to run a so-called relaxation. And what is a relaxation is basically you've stretched all of these things to their breaking point. What would these connective things look like in reality, right? So when they're not like at a temperature of, surface of the sun, or probably hotter in this case, actually. So we can run simulation. And what this did in the background real quick there is it spun up a Python process through all of the atoms and their connections and their locations over the ZeroMQ bridge into a real science tool, and then communicated the results back. So what you saw here is basically this interaction between Godot in Python over the 0 and cube range. And let's see, how much time was that? Like 5 minutes, 10 minutes? 10 minutes, I think, right? Anyone know? All right, I'll just keep going. So another thing we can do here is we have some, this was what we call the ring menu, which you can see some of our video game inspiration here. But it's actually turned out to be like a really good way for novices to sort of like be able to explore what is possible in the interface. So what I'm going to show you here is I'm going to download, import one of the big models here that we have. So it's going to show you the performance of everything. So this is 2 sets of wheels with some virtual motors that will actually rotate. Now on this laptop with this GPU, I'm not going to be able to actually do that in the time of this presentation. But if you have a more reasonable computer, you can actually do this relatively real time. And what we see here is if I select everything, we have about 6,500 atoms here being rendered. So should not touch technology. You can see this, like even on this laptop, this is all like running at 60 FPS. Totally fine. Let's see. We have integration with, I don't show that here, but we have, I will go to the continue with the presentation. So I think I wanna keep you from your lunch. So I want to talk a little bit about what went like particularly well with this project. And one of the things is, as I talked about earlier, the UX iteration was very painless. Works really well. Doing quick iterations was extremely cross-platform builds of Godot was also surprisingly easy, particularly since 4.4. Before 4, we had a bit of a problem on OS X at time. Molten TK worked, but it wasn't like necessarily the best possible experience. And GDScript, like this is a thing that I end up always talking about at least a little bit in every presentation, but like use GDScript, you do not need C# probably. Iteration times will be way lower, and the tooling is just way better. Interfacing with Python was really easy actually once we figured out how to do this sort of like simple networking support. Originally, we were trying to actually load the Python interpreter into the Godot project, into the Godot as a plugin, and that worked. And it has some benefits, but the big downside is that you lose this isolation, and as soon as you end up like loading a CUDA library through a Python thing and your system CUDA is slightly different, now things are, let's say, interesting times. Another thing that went really well is that the Godot editor itself holds up super well to a project of this size. I have it open here, and we have like the navigating the project is great. We have these different colors for different parts of the editor, and this makes it really easy for our developers to find the parts of the code that actually need to work. So things that were less great. So making sure that at least some of the creature comforts that people expect from the platform work is a bit more work than I had originally thought. So for instance, on OS X, people really expect this global menu bar thing to work. Whereas originally, when we designed it for Windows 11, we don't even have a menu bar anymore. And it turns out that that was not necessarily appreciated by OS X users. GPU use itself is still a little bit high, so we used this Godot low power modes to kind of limit the amount of FPS and things like that. But still, the amount of GPU that is being used, particularly redrawing a non-changing screen, is still pretty high. So it's not the most mobile-friendly application at this time. Let's put it that way. And another very interesting problem was that turns out that people who do not game tend to not install gaming drivers on their computer. Who would have thought? Right? So, particular like on OS X and Linux, this is actually not a problem because they're all the same drivers. But on Windows, if you just install your Windows 11 box and let it install your GPU drivers, you might end up with something that works. And particularly Vulkan doesn't necessarily work super well on those drivers. So having to tell particularly scientists who have their nice little Windows laptop and their Linux workstation that they really have to install the Radeon, Catalyst, Tro, whatever nonsense that's kind of annoying. So one of the things we're hoping to do to solve that is by on Windows use the Direct 3D drivers, and hopefully that will solve this problem because I believe that you can reasonably expect Direct 3D to at least function on a normal Windows machine. So conclusions as SDR, I think Godot is a great platform to do this with. I actually recommend this. If you don't have a strong desire to use sort of like native tool sets, Godot is absolutely a contender. And specifically, like if you were otherwise thinking of maybe using React Native or something like that, Godot is just that. It's just a better idea to use Godot. And I think that's the end of my time and also the end of my presentation. Thank you. Of course, I picked with an RSU 2 scale. Does anyone have any questions?
So this services and updated services other musical service for I think that this is that Zero capability supports in visualizing your simulations or the end scripts or presentation.
Yeah, that's the first use case of somebody actually using the tool was actually that. We added a picture mode so you can render your molecules without a background, and people have actually been using that in publication.
And that is
on aid for BBC. Sorry.
says was that should need to edit movie. Like once the goes up in money. Speed once at 8 plus Lucy and all these whatever situation we got to you know. Here's all that for your power.
Repeat the question. Repeat the question.
So this is maybe we should talk about this later because this is I think not this is really like this project related. So please find me later. But this was about technical question about how to find file formats and how to import them. And I think maybe you're probably the only one here that cares about it. I know. Which is really I care about it too. But let's not there.
Yeah, I had a question about display scaling. I know I picked this a while ago. Many things are better now, but I recall there being some issues about if, for example, if I have a 4K monitor and I'm like 50% scale, some issues where Godot either not utilize that or ready to solve. Did you encounter that, or is it better now?
So this was a question about whether display scaling works. So we haven't really had any problems with that since I got about Godot 4.3-ish. I run a 2K laptop at 125% scale, and that just works. So at least since 4.3, like we started on 4.2 and we did have problems then. But here now on 4.4, this seems to all work just fine.
When you're going to include custom Python environments and bridges and stuff, and then you're exporting it to like a whole application, are there any weird gotcha that you keep in mind, or is it just
So are there any gotchas trying to include third-party Python in exported project? No, not really. We just have the Python code in the Godot project itself under a Python folder. And in the export settings for the project, we just will tell it to include that Python, and that just works. They're all the way in the back.
Interested in making the ZMQ bindings add-on?
Oh, are we interested in making the ZMQ bindings an add-on? So currently it's a module, and it is part of the open source project. So if you want it, you can literally just grab it right now. We've not really thought about whether or not someone else might care about it. If there are people here that care about it, I'm happy to just put it in a source.
Yeah, so I don't know if there are any 3D nanotechnology quicker yet, but I wondered how you thought about
export? Like how difficult it was to have Godot write the file formats that someone else could use outside of Godot?
Okay, how hard was it to implement third-party file formats in Godot? It depends a little bit. So this world is annoying in the sense that some of these file formats date back to like the 70s, and they were like punch card compatible TM. So some of this is not ideal, right? So for instance, for the PDB file format reader, we actually implemented our own in GD script. But for the more modern ones, that sort of like the formats that were designed post punch cards, there are relatively good bindings in for Python science tools that can both read and write these. So we end up actually going through the Python bridge to use the normal tools that everyone else uses to suck this stuff in and also write it out. Any other questions, or should I let you all go to lunch? Okay, one more?
Yeah. Some of your UI was definitely like control nodes, or something looked very like bespoke in 3D. Well, what was it like going back and forth between the two types of, like is your 3D stuff control node secretly, or what's the dynamic like?
So our is the UI control nodes or is it regular UI? It's a little bit a mix of both, but the 3D pie menu that we have is control nodes sort of like in the background with essentially 3D textures, essentially. But going back and forth between them, because we had like our own gizmo system as well, etc., was really not very difficult. We just use signals to tie all of these things together. And the design is basically we have a sort of message bus inside the program where most of the signals end up and get sort of like pushed through the rest of the system. And that lets us mix basically whatever the hell we want in a very seamless way.
You were showing HP the ease that the editor you could like click on the nodes, and now I understand why you've refactored this part of the editor.
Yeah, I did a refactoring of the editor so that more nodes could be edited in the Godot editor. Yeah, that was one of the reasons. it got a little slow. Yeah, and it is fast now. It's fine. It's great. All right, I'm gonna let you all have some food then, and if anyone wants to talk about this later, feel free to find me after I've had.